Artificial intelligence is rapidly transforming the way software is built. In 2026, Java developers are no longer writing every line of code manually. Instead, they are collaborating with intelligent coding assistants that accelerate development, improve code quality, and automate repetitive tasks. One of the most powerful tools enabling this shift is GitHub Copilot integrated directly inside IntelliJ IDEA. The journey begins with setting up an AI-enabled development environment. By installing the Copilot plugin inside IntelliJ, developers can start receiving real-time code suggestions as they write Java code. Instead of manually implementing repetitive patterns like constructors, getters, service methods, or repository interfaces, the AI assistant generates these components automatically. This dramatically reduces boilerplate coding and allows developers to focus on architecture and business logic. Once the environment is ready, the next step is learning prompt-driven development. Instead of writing long blocks of code manually, developers describe the functionality they want using comments or short instructions. Copilot interprets these instructions and generates Java classes, methods, and logic accordingly. For example, describing a REST API for managing user accounts can lead to automatic generation of a controller, service layer, and repository structure following common design patterns used in Java backend development. Testing also becomes significantly faster with AI assistants. Developers can open a test class and ask Copilot to generate unit tests for service methods. The AI can automatically create JUnit test cases, mock dependencies, and even include edge cases that might otherwise be missed. Developers then review the generated tests, adjust assertions if necessary, and run them inside the ID. This process increases test coverage while reducing the time spent writing repetitive testing code. Another major productivity improvement comes from AI-assisted pull request work. When a feature is complete, Copilot can help generate clear commit messages and structured pull request descriptions. Instead of manually writing detailed explanations, developers can rely on AI to summarize the changes, highlight the purpose of the feature, and document the testing approach. This improves collaboration across development teams and ensures that code reviews are easier to understand. Documentation also plays a critical role in AI-powered development. By creating structured markdown files such as architecture, MD, or API design, MD developers provide contextual information that AI tools can use when generating code. These files describe the system architecture, design patterns, API structure, and coding guidelines. When Copilot references these documents, the generated code aligns more closely with the intended architecture and project standards. As development progresses, AI can also assist in implementing features directly from requirements. A developer can take a feature description from a task management system and place it inside a comment within the code editor. Copilot analyzes the description and generates the initial implementation, including domain models, service classes, and API endpoints. The developer then reviews the generated code, ensures that business logic is correct, and refines the implementation. Code review is another area where AI provides significant value. When reviewing pull requests, developers can use AI to analyze large code changes quickly. Copilot can identify potential performance issues, missing validations, or security concerns. Instead of manually scanning hundreds of lines of code, developers can focus on the most critical parts identified by AI suggestions. This speeds up review cycles and improves overall code quality. Teams can also automate parts of the review process by maintaining rule-based documentation files. A markdown file describing code review guidelines can define standards such as validation rules, naming conventions, or architectural constraints. AI tools can read these rules and automatically check pull requests against them, generating comments and recommendations during the review process. Advanced AI development workflows involve connecting AI systems with the full context of the repository. This can be achieved using Model Context Protocol servers, often referred to as MCP servers. These servers allow AI assistants to access project documentation, repository structure, and development tools in a structured way. With this context, AI can generate more accurate code because it understands how the entire project is organized. When contextual awareness is enabled, Copilot can generate much more sophisticated implementations. Developers can request an entire feature module, and the AI can create controllers, services, repositories, configuration classes, and tests that align with the existing project architecture. This level of automation transforms development from manual coding into guided system design. In later stages of the workflow, AI can also automate parts of the pull request lifecycle. After generating and testing code, the AI can prepare a pull request automatically, generate a summary explaining the feature, and suggest reviewers based on repository history. Developers then validate the implementation, verify that tests pass, and merge the changes. Continuous integration pipelines complete the process by running automated builds and tests. The developer's screen shows the build process, executing successfully, confirming that the AI-assisted implementation meets quality standards. This workflow demonstrates how AI can integrate into every stage of software development, from coding and testing to documentation and collaboration. The role of the Java developer is evolving rapidly. Instead of spending most of their time writing repetitive code, developers now focus on guiding intelligent systems that generate and improve software. By combining modern development tools with AI capabilities, engineers can build features faster, maintain higher quality codebases, and deliver software more efficiently than ever before. This transformation represents the future of software engineering, where developers and AI systems collaborate to create scalable, reliable, and well-designed applications. The developers who adopt these workflows today will be better prepared for the next generation of AI-powered development environments.